Good morning, friends. So let us start. Okay, so let me share my screen on WebEx also before we start. I hope you guys can hear me. Hello, can you guys hear me and can you guys see my screen? Okay, thank you, Jnana Prakash. One minute, we'll start. I just want to make sure that people can see my screen. Okay, so today's session is we are continuing on HBase itself. We will see how to develop the Java programs. Again, it's very straightforward. If you are a Java developer, you just need to understand Java-based HBase APIs, and you have to start using those things. So already, if you go to my GitHub account, click on NoSQL. That the repository is code. So if you go to my GitHub account, go to the code repository, and go to NoSQL. Here you can see HBase and DynamoDB. Cassandra is not done yet. We will be taking care of it later. If you go to HBase and click on pom.xml, so this is where you have to start anytime. Okay, so in pom.xml, we have to define the dependencies. So to develop HBase based programs, we need to at least have these two dependencies, HBase client and HBase common. So if you have Eclipse, so I am starting the Eclipse. So you can actually say a new project, file new. Okay, now it is in Scala mode. I have to change it to Java perspective, window, perspective, other, Java. I'm changing it to Java perspective. And now if I say file, new, Maven project. Okay. Click on next. Next. IT University and HBase. Finish. And in this, you go to pom.xml. And in the dependency section, you add these two dependencies. If you want to use Cloudera or Hortonworks dependencies, you have to create the repository. So there should be another tag called repositories, and then in that there should be subtag repository, and you can add whatever repository you want. That is how pom.xml work. Now, as we click on save, it is building the workspace, which means that it will be downloading the dependencies. Once it is downloaded, we can expand this one, and we can see the dependencies that are downloaded for the HBase purpose. And then we can start developing the HBase program. So first thing you need to understand is the difference between MapReduce and HBase. Okay, so MapReduce is a batch processing framework. So if you want to write MapReduce based programs, you don't directly connect to the cluster from your Eclipse. You test it locally, build the jar file, take the jar file to the remote remote production cluster, and you schedule your MapReduce based jobs using some workflow. Whereas HBase will be used for the operational purposes. Example is our LinkedIn endorsements. Okay, and in that case, it has to be up and running all the time. It has to serve the real-time traffic. So if you are familiar from from web application development, the jar file has to be deployed on some application server or web server or some server which will be up and running all the time, which have the jar file, and that server should be configured to connect to the underlying database. Okay, so you have to use JDBC type of programming as part of your application to connect to the database um, and do the necessary operations in the DAO layer. If you are from Java background, it is called as data access layer. I do not remember what is O, but DA stands for data access. So as part of the data access layer, you will be generating the SQL, or you will be using the ORM tool to connect to the underlying database. So in this case, HBase should be treated as a alternative database for some of the use cases, such as recommendation engines, endorsement engines, etc. And you have to deploy in a web application. Okay, and here, if you go to getting started .java program, you will see the HBase code. And if you are familiar with typical RDBMS, what you do means you can actually connect your Java program to a remote database by providing the IP address, host number, and IP address, port number, database name, etc. And you have to use something called TNS listener. If you are from Oracle background, you have to use something called TNS listener or service listener, and you have to give all the necessary information to use the service to connect to the database. So when it comes to HBase, the role of the listener will be played by quorum, zookeeper quorum. So you have to give the zookeeper IP addresses. So how to get this information? You have to go to your target cluster. Typically, this has to be externalized. You should not hard code like this. But for simple programs, I am showing. So you should externalize based upon the environment you are trying to run. The program should inherit values from a properties file and use those values to connect to the intended target HBase cluster. Okay, so now we are going to the configuration files, etc HBase conf, and also you can go to the browser. Okay, either you can do from the browser or from the command line. So whatever you have access to. Okay. In browser, you have to go to the configs and search for quorum. So there are 3 IP. How many other? 1, 2, 3, 4 IP addresses. So you can use all these things as part of your program. Okay, but those are private IPs. When we try to directly connect from our application, it might not work. So let me try new class demo. So demo. As I have So we can actually copy these things. We need to get the port number also. So port number is 2181 client port. This is the one which you need to use. So port number does not change. And quorum, as we are trying to connect using these ones, you can specify all the servers. It load balances automatically. So you will have advantage if you give uh, all the IP addresses for all the servers that are configured as quorum. So even if one goes down, still your cluster will be available to run your programs. Okay, and here once the quorum and port number are defined, we need to create a connection object so that we can establish connection to the database. Then you can actually get a table by passing the table name, and then you can perform whatever operation you want. Okay, so in this case we are trying to scan the data or whatever is available. There should be another program. Actually, I gave lot more functions as part of this. Let me just check it out real quick. Because as part of my videos which I have created earlier, I have given functions for put, get, scan, etc. Now, okay, the same program have everything. Okay, first what it is trying to do is it is trying to check for a table called demo. So we are creating a table object. Then we have to create a scan object, and we have to apply this on. We have to apply the scan object on the table by passing the get scanner. Okay, so as I mentioned to you earlier, scan is primarily to select all the tables or select a range of values from the table. So in this case, I am only using a CF1, column 1 and column 2. So I need to have some data satisfying these column families and column names. Okay, so let's generate the data. Then I will actually show you. So I am logging into HBase. And before that, if I have to run the program directly using my Eclipse itself to validate, I need to make sure that I'm able to ping these servers from my PC. If I'm not able to, I thought I have it's in my host file. Okay, probably it might be down. Let me check this one. Even this is not working. Even if one works, that is fine for us. None of them are working. I think they have changed the IP addresses. Okay. Let me validate these things. Let me go to etc host and comment these things out. Okay, it's in the read-only mode. Now let me try pinging. Okay, telnet. Okay, I think they have disabled the ping. That's why it is not working. So let me see. Telnet. It's not working. Probably they might not have opened this port from the external world, so we cannot test it directly on the CloudX Lab from our PC. We can compile the program on the server itself, and it should work. So let me try that way. Okay, that's it. So I'm connecting to the tech cluster, and now let me ping these things. I am not sure whether they have telnet or not. NC. They have NC. So now let me try this one. Yeah, it is working. Okay, so this is working. From here it is working. So I can create the program here itself. Create here hbase underscore demo. Okay. So instead of using IDE, because they did not open this port number to the external world, we cannot directly test it from our Eclipse. Otherwise, we will be able to do it. Okay, so I am actually copying this one. Vi. What is the program name? Demo.java. It's been a while since I wrote from the command line, so I'm not sure whether I will be able to execute this one, but I will give it a try. Okay, save it. Java C. Okay, we need to have the dependencies and all. Yeah. Do we have Maven here? Yeah, we have Maven, so we have to create a Maven project here. Okay. Anyway, we will try to run on some other cluster. Let me see. Let me try it on my local Cloudera Quick Start VM rather than doing it on the CloudX Lab. If we create Maven project on the terminal itself, it will work. I have to download the dependencies and all. So first, let us try creating this table. Meanwhile, this will start. So I'm launching HBase shell here. Okay, I have to do it in the cloud here itself. I'm sorry. So I will take care of here itself. So I'm launching HBase shell. Probably the services are not up. Yeah, let me list the tables here. Okay, and if config -a so that we can get the IP address. This is the IP address. We need to validate that I can ping it from my machine. It is working. So most likely this time it will work if the services are up. Okay, so services seems to be not up. And also I have to, okay, HBase is not here. Add a service, HBase, continue. Okay, so now it is trying to run. So meanwhile, let us see the program. So here we have the example for scanning the data. I created the result set for all the data. If you want to apply the filter, you can apply the filters also using the scan object. And you need to deep dive into those filters and determine which filter should you use based upon your use case. Typically, at the scan level, if you have multiple rows and if you want to scan uh, the records based on range on the row key, then you can actually apply those additional filters at the row level first. And then even in the values you get, it is called as projection. So for example, if you write a select query like this, select star from uh, table 1, where etc. Okay, so this select is also called as projection. Okay, and if you want to get only few fields from the data as part of your scan function, you can do that also. And you can do that based on accessing the fields by name or by position. So for example, let's say there are 10 columns, C1 to C10. And when you store in HBase, those column names will be in an order, as I have demonstrated yesterday. So if you want to select C2, C6, C8, C10 to only process the data in those fields, you can do that as part of the scan. You have to apply additional filters or clauses. Or if you want to just get from C2 to C6, you can apply column range filters also. 1 minute, okay? Sorry, I was on mute on the Hangout. Sorry for that. Anyway, let us see. So it's not running for some reason. We will see, but you can try it out. It should work. You have to troubleshoot if it hang in your case. If it throws error, I can actually troubleshoot. At this time I cannot because it is not throwing any error. It's just hanging. So if you have to build application for your CloudX lab, you either you have to ask those CloudX lab guys to open up the port 2181 and then run it from your Eclipse itself, or once the program is ready, you can just click on this. You can say means you have to have those IP addresses here, and then you can actually say Maven install. It will create a Maven jar file. It will create a jar file, and you can ship the jar file to the cluster, and you can run the jar file using jar command or Java command. You can run the Java programs which are in jar file using either, I think you have to use Java command, and you can run it. Okay. Otherwise, you can run it from the Eclipse if you have access to. But you cannot use Hadoop jar because Hadoop jar is primarily to run the MapReduce jobs. In this case, it is not a MapReduce program. It's a plain Java program. And whatever way you can run the jar file, the plain which have the plain Java programs, you can run. I think the way you can run is using Java. I do not remember at this time exactly. Java-jar or something. Or let me see in the jar. Yeah, this is how you can run. No, this is not the way you should run. Yeah, I think let me Google it real quick. So running the Java function and Java class from jar. So this is how you can run Java-cp, give the jar file name, and then use the class name. Okay, and for the full instructions, I already have few videos on my channel. So if you search for IT University HBase, so in this you can see how to run as I have demonstrated here. And in this case, I have taken a little bit real world use case of our New York Stock Exchange data. And you can watch this video to see how we can actually run the programs against the HBase database. Okay, that being said, if you have any questions on HBase, let me know. Otherwise, we'll move on to the next topic, which is Spark data frames. Okay. So I will give a minute. If you have any questions, you can ask. Otherwise, we'll move on to the Spark data frames. So the question is the quorum parameter finding same on Cloudera VM? Yes. In our case, quorum is, we have only one VM. So I have, so let me finish up this Ramesh's question. When it comes to quorum parameter, it's the same. You just have to go to etc hbase conf and you have to get it from there. Okay. So the next question, what Jio is asking is, could you please show how to use HBase from Spark? No, I have not tried yet. It should be pretty straightforward because Spark, if you are using Scala, you can actually invoke any of the Java APIs, and HBase APIs are nothing but Java APIs. So it should be pretty straightforward, but I haven't tried yet. because Spark and HBase are not a very popular combination. People use Spark and Cassandra in some of the projects, but Spark and HBase is not very popular. So whenever people want to deal with HBase, so if you think about it, HBase is an operational database. We don't process the data in batches that often in HBase. Okay, if we have to do in batches, then comes the requirement of um, either Spark or MapReduce. And as HBase is native to core Hadoop, which is HDFS and MapReduce, people tend to use MapReduce itself if they want to do some batch processing on the data which is stored in HBase. Okay, Spark, they don't use Spark for those scenarios. Spark is rarely used for batch processing on the data which is which is residing on HBase. So I have a long-term follower where he told that they will use Spark for everything else, but for HBase they only prefer to go with Java. Okay, and means when I say Java, Java-based HBase APIs rather than using in Scala or Python. So here, HBase is a database, and Scala or Java or Python are programming languages. So if we have to implement something which is operational, we have to just use the programming language of the choice, whether it is Scala or Python or Java, whatever is applicable or whichever is familiar to you. So when it comes to developing those real-time applications such as recommendation engines, we only use Java when it comes to HBase. And then the second use case is batch processing of the data which is in HBase. At that time, either you have to use MapReduce to do the batch processing, or you have to use the Spark-based batch processing using Scala or Python as programming language. So when it comes to HBase, that batch processing does not happen that often. So even if the batch processing happens, people fall back on MapReduce than Spark, because MapReduce and HBase are tightly integrated compared to Spark. So people tend to use MapReduce to process the data in batches in HBase. Okay. So that's the theory part of it. I don't have videos for the how to do the, or I don't have content about how to do the MapReduce and all those things. If we start doing that, we have to spend 2-3 days only on HBase. Okay, and HBase is not very popular. Again, you have to give the weightage for each of the technologies which we are exploring. Instead of feeling that we are missing something, we should give weightage. And if you think about 100 projects or 100 modules in big data, probably less than 5% will use HBase, and out of them also very few projects will be using will be doing the batch processing on the HBase tables. Okay, so any other question? One more thing I told you that I will explain is how everything work together. Means when it comes to real-time streaming and using these different technologies such as HBase, Kafka, Flume, etc., how these things will work together to get the output in the form of what we are looking in LinkedIn endorsements or Amazon recommendation engines, etc. So I will cover that now. Rather than going into Spark data frames, let me cover that first, and then we'll get into the data frames. So I'm showing you the endorsements again here. So these are the endorsements, right? So now if you think about it, people like you will endorse me in different technologies. And I don't need to see immediately. There is no transaction involved. People are just endorsing. Even if it takes some time to reflect on in my report, I'm okay with that. But the data has to be saved persistently. Okay. So they use some NoSQL database. It need not be HBase. So the data go to the raw table. Let me get my whiteboard in a moment. I am connecting it. Okay. So let me open the essentials. So we have one collection C1 which have actual raw data of our endorsements. So there will be application server layer here, and then clients will be using the browser, or the users will be using the browser, and they will be endorsing. The request will go, so these are the browsers, and the request will go through some intermediate server. We can call it as the application server or web server, whatever it is, or API gateway. These days, API gateways or API gateway servers are getting more popular. So you can safely say there is a server in between the browsers which are being used by the users and the underlying database. So when the request go to the server, the data will go to the collection. That is one path. On top of it, there is a web server logs also here, right? So this information which is being written to the database will also be written to logs. Okay, so all these entries will come to log file. These are called as web server logs. In Java we typically use log4j, and we can log whatever information we want. And how the log records will look like? The log records will look like this. So there will be a timestamp when the log is generated, and then whether it is info or error or warning, etc. And then additional information. So what, for example, let's say this is endorsement application. Probably there might be application name here, and then details about the endorsements. Okay, so typically these days people are using JSON to store the data. This entire information of endorsements, because each individual can endorse on multiple technologies. So this guy might endorse on 3 technologies, this guy on 1, this guy on 5. So all these things has to come in a proper format which can be interpreted. So they use something called JSON. I hope you guys are familiar with it. If you are not, you should be familiar with the JSON format. It's a very important format for these days, and almost all the applications are slowly getting into the JSON from XML because it's much more lightweight and robust. So you have to explore that. Okay, so the information will be typically stored in JSON, and then so the data will be in logs, and then there are tools like Flume and Kafka. So Flume is nothing but agent which will be polling these logs and getting the information. Okay, to poll and get to the information, we have to use Flume, and then from Flume you can actually queue up the records, whatever you are getting from these log files. Instead of processing one record at a time, you can pool the records, and either you can Flume will have a source. So the source for Flume is this one. We will see a little bit on Flume next week. So Flume will treat this as source, and then there is something called channel in between. Okay, and then there is a sink. Again, it is taken care by Flume itself. So Flume get the data from source, it channelizes through it, and even channel is the component of Flume itself, and then data has to be flushed into sink. The sink can be a database or a Hadoop cluster or a HBase database. It could be anything. The target can be anything. Sources are typically logs. Targets are a database, and then there is a channel in between. This channel can be a memory channel. Okay. So before pushing, after getting the data from source, instead of pushing one record at a time, it has to queue up. So that queuing might happen in memory. So there can be a memory channel. There can be a file channel. So instead of storing it memory, if it runs out of memory, there will be issues. So you can also store it in file. And then there is one more thing called Kafka. So the channel can be Kafka. So Kafka is a queue. I will explain that when I talk about Flume and Kafka next week. So you use Flume. Typically, LinkedIn uses Kafka. Kafka is LinkedIn's invention. Okay, to queue up the data. For reading the logs, I'm not sure whether they're using Flume or not. But for queuing, they use Kafka. That is, I'm 99% sure. And then again, they can push it into a target through directly into the database, or they can also do something called streaming analytics. Okay, that's where Storm comes into picture. Storm or Spark streaming comes into picture. Okay, so let me explain it from that perspective also. So we have the log file. Well, the raw data have already gone to the database. So the database, sorry, not this one. Let me close this one. Don't save. Let me move it a little bit side. So the first when one of you endorses, yeah, we have to capture the raw data. The raw data will be stored into the HBase database immediately if they are using HBase. But for generating this report, okay, for generating this report, we have to get these logs. Okay, so that's where this Flume Kafka comes into picture. So once Kafka gets the data, now we have to update the second collection, C2, which will have the aggregated data. Okay, so from log, you got the log entries. You use Flume to read the data, and then channel through Kafka. So these are all. This entire stuff is called is Flume. So this is source, this is sink, and this is channel. And we are using Kafka for the channel here. Means we can use Kafka for channel here. And then what we can do is we can actually port this data that is coming through Flume into something called Storm. Okay. So what Storm can do is it can means whatever batch you get. For example, let's say in one batch of Kafka channel, you get 100 records within 2 minutes. Okay, within the 2 minutes, you got 100 records. Using those 100 records, you can actually say, I want to update the aggregated collection. So the aggregated collection, what it has the the skill which is being endorsed, total number of endorsements, and 12 latest endorsers names. That is the structure of the aggregated collection. So whatever needs to be done on these 100 records in streaming fashion, that logic will be invoked using Storm. So Storm is used for streaming analytics. Alternatives for Storm are Spark streaming and Apache Flink. So a new technology called Flink. So you can use one of these technologies. Flume or Kafka actually port data into these, and then you can do the real-time analytics. In this case, what you have to do, let's say one of you endorsed me on Spark, right? So what it has to do, it has to increment the aggregated value, means the number of endorsements value, and then it has to uh, add one more entry to this collection and remove the last one. That entire logic can be done. We just have to increment the existing value, append the new endorser's name into this aggregated collection, and delete the oldest one out of the existing ones, and then you will have the the collection reflecting the current state to generate this aggregated report. That entire logic can be done using Storm in real time without going through MapReduce phase later to apply this logic. That's how LinkedIn can design their application by getting the data from logs every 2 minutes. So they can apply this streaming analytics, and within 2 minutes, people who are looking at my profile get the latest report. Okay, so this is how you can implement and use different technologies to design the applications. So in this case, we are talking about HBase as a database or any NoSQL as a database, which will have the collections. And then to read the logs, we have to use Flume or Kafka or both. And then if we have to do the streaming analytics, we can use Storm or Spark Streaming or Flink before storing the data into the NoSQL database. Okay, I will give another example. So this is for a retail company who have an e-commerce platform. Okay, so that company, it's a major retail store in US, and this is the design which I have worked on. So that company have several databases. So typically, there is a one database per store or one database for n number of stores. Okay, and from that database, so they have stores, physical stores, and also there is a e-commerce platform for them. Okay, so people can go to the e-commerce platform and can buy a product. When they try to buy a product on the e-commerce platform, if the product is available in the nearby store, so those guys, the retail company want to recommend the guy to go and pick the product immediately instead of waiting for the shipping. That is the intention of the project. So it's a pretty big store, and the traffic is very high on the relational database. So to show the close by store details, when people try to search for the product, they cannot go to the databases of the stores and get the information to show whether it is available or not. They cannot go to the live live databases which are supporting the application. For example, there are 3 stores, let's say S1, S2, and S3, and I'm trying to buy a product from Dallas, and Dallas have, let's say, 4 stores. In Dallas, there are 4 stores of that company. Okay, yes, 4. So when I search being in Dallas, if the product is available in these 4 stores, it has to show that product is available in these 4 stores, and go and pick it up whichever is nearer to you. That is the recommendation the application have to give. So to check whether the product is available, when we search the product, we will typically search by product name, and then it will generate the SKU ID. Using the SKU ID, if it has to go through all these 4 databases and check whether the product is available or not, and then if it has to recommend, it does not work that way. It is not very, user experience will be bad, and even there will be contention for means the databases might have some impact because of this external traffic, and those guys don't want that to happen. So what they have done, they have actually do a ETL, get data once every day from each and every store, and preserve it in a traditional RDBMS. So what that RDBMS database will have is, it will have this QID, and for each product, it will have it will try to maintain the quantity of the product available in each of the store by end of the day. Okay, so when they do end of the day batch processing, they don't get accurate results, because this company is pretty big and there are too many transactions, and by the time they get the data and the process, and by the time it is recommended to the client, to the user who are trying to buy the product, the product might have been sold out. And when he go to the store for that product, if the product is not available, then the customer will be upset. Okay, so that's when, and also the database is being exploding because we have that company have hundreds of stores in US, and if they have to maintain in a traditional RDBMS for each and every product, then the database will explode, and it's very tough to get these reports and provide proper user experience to the users. That's where we have used something called Cassandra. Cassandra is another NoSQL database, which is alternative for HBase. It also stores the data in similar fashion. And then we have built a intermediate layer where we get data from all these databases every 2 minutes. So every 2 minutes, there will be a connection going from this middle layer, go to the database and fetch the results about the current status of the products of that store. We will run a simple query on a couple of tables, get data every 2 minutes, and then update the Cassandra database about the current status of each of the product in the store. And we will not get data for all the products. We will only get the data for products that are being sold in last 2 minutes. So let's say last 2 minutes, there are 100 transactions on this. So we can get those 100 transactions, and for each transaction, you will have a SKU. Means for each product, each item in the transaction, you will have SKU. Using that, and also the quantity which is being sold, we can actually subtract the values in the Cassandra database. In Cassandra database, we have only store ID, product SKU as key, store ID and SKU as key, and number of products available at the time as value. Okay, so using store ID and SKU, we can determine how many number easily. So when we actually use this one, every 2 minutes we get the data, and if there are 100 transactions and 1,000 products that are being sold in those 100 transactions, that those 1,000 products will be updated just by reducing by the quantity that is being sold as part of those 100 transactions. And then the Cassandra database will have 2-minute old data, and the miss ratio of customer going to the store and missing the product is almost negligible. Okay, so there is a question. These transactions are tracked from all DBs across globally. Yes, so this is Cassandra is a centralized data store, and this middle tier can parallelly go to all the stores and get the data. So there is no load on one database. So the load to fetch this 2 minutes data is in the middle tier. So we use it. I think I did not remember what technology we have used for the middleware. So that middleware is capable enough to fetch data from multiple stores at a given point in time, and get only the transactions that are happened in those 2 minutes and apply onto the Cassandra database. So the middle tier will have the logic of fetching the data and then updating the Cassandra records in the Cassandra database. Okay, so this is another real world use case which I have designed, and I'm not sure the current status of this, but the design was means they have accepted the design. Means I was part of the design. I'm not the one who actually designed the complete thing. I was part of the design. Design was accepted, but I was not part of the implementation. Okay. So any questions here? How will you hold the product like if product is ordered from e-commerce? So from the store perspective, it will only give the current scenario where the product is available. For example, if the product is available in S1 and S2, I place the order. Until I go and pick it up, the product is not transacted. We have paid the money online, but the transaction is complete only when either product is shipped to me or when the product is given to the guy. So in this case, if the product so again when they report, let's say S1 have 10 of those things and S2 have only 2, you will get that number that S1 have 10 and S2 have 2, and probably we can warn better to go to S1 than S2 because you have more products. If you go to S2, if it gets sold out in next 1 hour, you might not get the product when you reach there. So that's the warning we will give, which is acceptable. So that's how we there is no concept of holding, and this guy cannot say that please hold for me, I'm coming and picking it up. That guy cannot do that. It's just a recommendation. Instead of waiting for shipping of the product to the store and go and grabbing it, if the product is already available, he can go and get it, and it will give the true picture, which is 2 minute or 5 minute order. And once you go and buy the product, then only the transaction is complete, and then the database will be updated, and the Cassandra database will be updated automatically. So the question is, does the middleware acts like streaming tools such as Kafka or Storm? So here there are two things. One, getting the data from the database. So, and then applying the logic which is required to update the final table. So streaming comes in that layer. So middleware can be anything. It could be Flume and Kafka combination. It could be our traditional middleware, which connect to the database and get the data. But that data, instead of directly storing into the database, you can source it to Kafka or any other technology, Spark streaming, etc. And then you can actually apply the logic over there. So it's a combination of several things. So why can't MongoDB instead of Cassandra? You can use MongoDB also. MongoDB, Cassandra, and HBase are alternatives in most of the cases. But MongoDB performance is a little bit on slower side compared to HBase or Cassandra because MongoDB gives you a lot more flexibility from development perspective, which compromises performance a little bit. You can use MongoDB also for these kind of use cases. Yes, so that is correct, Ramesh. This is the same model for building the recommendation engines, feedback retrievals, but recommendation engines is a little bit more complicated. Here we are doing a very basic suggestion kind of thing. Go and pick the product immediately instead of waiting. But recommendation engine is a lot more complex. For example, if I go to Amazon and search for lapel microphones. Okay, so you get the list of the products. And if you click on one of those things, you see here swap by category. So it's a recommendation engine. And also if I click on one of those things, okay, here you can see the average customer review. If you want to just see the products which are best in feedback, you can filter out over there, and then you can actually do the pricing filtering also. Let me take a little bit better example. Samsung 55-inch TV. If I click on this, you see here frequently bought together. Okay, so this is called as affinity. When we typically buy the TV, people tend to buy wall mount. If it is not available along with the TV, they prefer to buy wall mount for these LCDs. So this is one type of recommendation. And depending upon the product, the recommendation has to change. Okay, and then customers who bought this item also bought all these things, HDMI cables and sound systems, etc. Okay, so this is called as recommendation engine. So in the back, so the way the recommendation engine will work is, I will explain that example also. So you have databases. And you have web server logs. So for example, if people buy the product, the transactions will be stored in database. If visitors just visit the website and add to the cart and then discard, there's no point in storing that information in the database typically, but that information can be logged into the loggers, and then we can actually do the heavyweight processing to understand the buying patterns or the selection patterns of the visitors who are discarding the products. Okay, so you have the database, you have web logs, and then you have distributed processing engine or Hadoop cluster or big data cluster. Okay, so you get data from this one, and then in this case you cannot use HBase or anything. You have to dump the data into HDFS, and then you have to either use Spark or MapReduce to apply those algorithms. If the algorithms are already available in MapReduce Mahout, you can use it, or Spark MLlib, you can use it. It's a heavyweight batch processing, and then whatever is the output, it has to be stored in a NoSQL database such as HBase, Cassandra, MongoDB, etc. So here, the periodic batch processing need not be 2 minutes. It can be 1 day, it can be a week, etc. We are just trying to identify the general buying patterns. Okay, so we can use whatever SLAs we defined to process the data for the recommendation engine. We will be processing in an anonymous fashion. We don't try to understand who is buying what. We will try to understand what are being bought together. That is more important than who is buying what. For some other cases, understanding the demographics and what they are trying to buy can be valid, but for recommendation engine, it need not be valid. So we process the data using Spark and MapReduce. Whatever output comes, okay, that output will be stored in either HBase or Cassandra or MongoDB. So when they store in HBase or Cassandra or MongoDB, the key can be the product ID, and the value can be the recommended products for that product on different affinities. Okay, the affinities could be the price-based affinities. So for example, if you try to buy a Samsung 55-inch TV, and if you want to buy a music system, you tend to buy a premier music system like Bose or Harman Kardon. So recommendation of that is more relevant than any other thing. Similarly, there can be category-based affinity. So these are all category-based affinity examples. Uh, uh, we tend to buy HDMI cables along with the TV, wall mount, etc. And also there are other affinities which might not be relevant to the electronics category, but home category. When we think about home category, if you have a 55-inch TV, you want to have a good furniture along with that. So people might buy the matching furniture along with the TV, and that is another kind of affinity. So we need to apply all those affinity rules as part of our processing logic, which we do it here, and then store in the form of key value pairs of handful of products at different affinity with different affinities, and then we have to recommend those things when we actually try to search for a product. Okay, so that's how the recommendation in Indians work. It's a lot more complicated than the earlier examples. Okay, so let's get on to the Spark streaming. We will start and we will continue as part of the next class. So first, let us understand what is data frames. So we have Hive to run the Hive queries. Okay, we have MapReduce or Spark to process the data. Then why there is another concept called data frames. So the Hive does very good job storing the metadata in metastore and providing you the facility with an interface similar to SQL to write the SQL queries to process the data. Okay, but the caveat is you have to create a table if you have to write a Hive query. And then you can only, once you create the table, typically you process the data using Hive or Pig or MapReduce. With Hive, you can use Hive type of queries. With Pig, you have to use Pig scripts. With the MapReduce, you have to write complex MapReduce logic. Okay. So, and they are tightly coupled, means whatever features that are available in Hive, you might not be able to use it in MapReduce. So what modern programming languages such as Python, R, etc. have done is they have created a concept called data frames, where you don't need to create the table upfront. Okay, as the data come in, if there is a metadata along with the data, apply the metadata, create a data frame out of it, and apply the data frame on the data. Once you create the data frame on the data using the metadata which comes along with the data, for example, one of the client have decided to send our New York Stock Exchange data. Let me show the New York Stock Exchange data for this. We have this file. Okay, and if you look into the file, it has 7 fields. Okay, so you can understand what each field is, create a Hive table and run the Hive queries. That is one way of doing it. Other way of doing it is, let's say today we got these many files with 7 fields in it, and starting from tomorrow they might change the structure, or the structure can be dynamic. Okay, but there will be a fixed structure, but it might change over time. So in that case, whenever there is a change in the structure, you have to review and you have to alter your tables in Hive, and then only you can write the queries. Otherwise, you will not be able to write the queries. Instead, along with the data, if they also give the structure to you or metadata to you, if you can apply that metadata on top of the data and create the table at runtime itself and use whatever data processing framework you want on top of the structured data, it can be a lot more feasible. That's where Python and R have come up with a concept called data frames, wherein there is no predefined table, but we get the data and the structure along with the data. We apply the structure on top of the data, create a temporary table or create a table, and then we can write the queries. So once you see the example, you will understand. Okay, so data frames is uh, primarily to create tables on structured data at runtime instead of pre-creating the table. That's the only difference between Hive and concept of data frames. The typical way of creating the tables and data frames. In data frames, you don't need to pre-create the table. You just have to create the table at runtime, understanding the structure of the data at runtime. There is no pre-creation of the table. That is the most important part of it. Okay, now let us understand the data frame operations. There are several operations which we can apply on the data frames directly. So once we create the data frame, right, we can write a query, or we can apply these data frame operations such as print schema, show, select group, ag, sort, and many more. Okay, so let's see the example about how we actually try to create the schema. Okay, so either you can use Eclipse IDE and follow these instructions, or you can directly go to the Spark shell also. So in this case, I'll be using Eclipse IDE itself, and I am changing the window perspective to Scala perspective. Okay, and then I am launching Scala interpreter. Let me go to the material. So first we need to create the Spark configuration object. Okay, we have to import these things. So let us import Spark conf. I will come back to the dataset is relatively new concept. I will come back to that as part of the next class. First, let us go through the data frames. Okay, so let us create the configuration object. And then we have to create the Spark context object. Okay, I have to import Spark context here. And then I have to create the Spark context object. So up to here, it is same. We import configuration, context, and we create the Spark configuration and Spark context object. Okay, and now we can actually create SQL context. So if we have to use data frames, we have to create SQL context. So here I am actually importing these two. Okay, and then I'm creating the SQL context. So if you have to use data frames, you have to use SQL context. So we have created the SQL context, and this is just standard process. There are certain inherent functions which we have to use. To import all those functions, we have to do SQL context dot implicit dot underscore. So whatever the APIs that are available under this, we can use it downstream. Okay, if you have to use a data frame, you have to do that. Now let us understand how to read the data. First, I will try to read orders data. This is orders data. Okay, if we go to this location, so that is input path. So if we go to this location, there is orders and order items. We want to read the orders data. Okay. So this is what will read the orders. This you already seen, so I'm going a little bit fast. Okay, so let me name it as orders only. The orders ds. Let me name it as orders only. So we can validate by saying orders dot take of 10 for each println, just to check how our data look like. Our data is comma separated. Now, if you don't have access to Hive, what you have to do? You have to apply the delimiter, extract the data, and then you have to apply our transformations and actions, which is quite cumbersome. So if you have to aggregate, you have to write an n number of lines of code to do the aggregation and get back the results. If we can define the structure on this at runtime, and if we can actually run SQL queries, probably our complexity might go down significantly. That's where the data frames comes into picture. So to implement the data frames, first what you need to do is, especially with respect to Scala, you have to create something called case class. So I will explain what is a case class. So there is a difference between class and case class. This is the new term compared to Java. Okay. So what case class is? So for example, you might have heard about POJOs, plain old Java objects, where you have a number of variables, and for each variable there will be a getter and setter method, and toString, hash code, those functions, whatever you want to override, you override in that. Okay, that is the purpose of POJO or plain old Java object, where it's the same class, but you have to define all those attributes and then getters and setters methods of those attributes. Whereas in Scala, you don't need to do that if you define the class as case class. It's like a POJO. You are defining a POJO. The getter and setter methods are automatically available to you. Okay, so that's the purpose of case class. So to use our to use data frames to define the structure and map to a object. So to define the structure, we need to create an object, and we have to map our data to that object. That's why we are creating this case class called orders. We just have to give the attribute names, and automatically the getters and setters will be managed internally. You don't need to worry about getters and setter methods. Okay, that's the purpose of case class. We have to use that when we try to use data frames. Now we have to apply the map function. So this is the map function on the orders data. Our data is delimited by comma. Okay, here if you see, I am writing a multi-line code. Let me copy this one to here, and then orders is our RDD name, which we have created earlier, and we have also previewed the data. So on that orders, we are applying this additional logic. Okay, so in the map we are writing multi-line code. We are creating a variable called a, and we are actually splitting each and every record, which will create an array. Okay, so for example, if this is a string, okay, and then if I say val str equal to dot split comma and hit enter. Now what happened? It has created a object of type array of string. So str is of type array of string, and that array have these 4 elements. Okay, so it returns an array. So we can access so there are 4 columns in that array: A0, A1, A2, A3. And as we are trying to applying split function on a string, whatever comes out of it, each and every element is of type string. You can see it here, it's an array of type string. So but as part of the case class, we are saying order ID as integer, but we are getting a string. So here we have to cast. That's why I have applied toInt. This toString is not mandatory. You can ignore that. Even if, without that, it will work. And then you have to say .toDF. Okay, then the data frame will be created. Now, the data type of orders df is nothing but a data frame. Once you have the data frame, you can apply several data frame operations. So you can write queries, which I will show tomorrow. Today we will primarily focus on these various data frame operations. Okay, so once you create the data frame, you can say orders df dot print schema. It will tell you the type of your schema of the data frame. That is one thing. And if you want to preview the data, you can say orders df dot show. It fetch few of the records to preview how the data look like. And then you can actually select, you can group, aggregate, sort, you can do all kind of operations using data frame operations themselves. Instead of using our core transformations and actions, we can actually use these data frame operations also to get the information. For example, if I just want to get order ID, once the data frame is created, I can say like this: select of whatever field I want to see. If I want to filter, I can apply filter, and like this. So let us see these things. So now if I do orders filter, again the output after the data frame operation will be data frame itself. So here if I say show, now I will get only completed orders. And if I want to get only one field rather than everything, I can say orders filtered dot select order ID and then show. You can see only the order IDs. So you can actually do a lot more complex operations also. You can aggregate, you can join, you can do whatever you want. So that is about data frame operations. So this is one way of processing the data once you create the data frame. Similarly, we can use SQL also, which I will show tomorrow. You can do Spark SQL and try to apply the queries. Try to process the data writing Spark SQL on top of data frame. Once the data frame is created, either you can use native data frame operations, or you can use SQL, or you can come up with your own framework to process the data. It's up to you how you want to manage once the data frame is created. Okay, so we'll continue as part of the next class on data frames. And also I will try to give you an overview about Flume and Kafka. Then after next class, we will start getting into setting up the environment. I will demonstrate about how to set up the environment so that you have fair understanding about it. And also, if you are interested to set up the environment, let me know. So I am actually working on a platform called ovh.com. Okay, people who have 10 plus years of experience who just want to build a cluster in one shot. AWS is a little bit expensive, and you have to stop and start. It can be counterproductive. So these guys charge around $79. Okay, but I'll be charging $150 from you. I will give 1 month lab access, and you can take that 1 month to build the cluster, 6-node cluster, and that $150 includes the $79 from OVH. Okay, so you can actually try setting up the environment. I will provide you the support in case if you run into any issues, and you will get fair understanding. And also when I give the environment, instead of just giving the OVH server directly and leaving at your mercy. So by default, you will get server like this, and you have to start from setting up the operating system and several things. Instead of giving you like this, I will give you the environment something like this. And make sure you are determined to complete it within 1 month. If you could not complete the setup within 1 month, then again you have to pay additional $150 for each month. But the beauty is you will get dedicated environment to you, and you can start from scratch, and you can actually set up the environment. So it will take little time here to get this, get the access to ESXi. I'm not sure whether you are familiar with ESXi or not. It is an hypervisor which will create the virtual machines. Okay, so here I am logging in. Password. You will get environment like this. You have 5 virtual machines, 0, 0, 1, 2, 3, 4. Okay, and once the environment is set up, so it will look like this. Okay, so this environment is set up on this OVH platform, and this is how the ESXi will look like. So you don't need to worry about setting up the operating system and all those things. I will take care of it, and I will give you environment with operating system. Either you will get 5 virtual machines like this, or you will get 5 Docker containers using which you can set up the cluster, the way I will demonstrate next week. Okay, so let me know if you are interested. And this is, we are trying this for the first time. That's why we are actually giving it for so cheap. If it works out, I will try to take the Hadoop administration courses also seriously, and provide the lab for the students and train them appropriately end to end about how to set up the cluster, how to enable Kerberos and everything over a period of a month or 2. So that's the, we are trying to come up with content in that direction. And also in this environment, we are also setting up a 8-node cluster. I'm in the process of setting it up. That's why it is taking a lot of time, and I'm not publishing a lot of content on my channel. So the lab will be available probably by end of this month. When I say end of this month, not October, November 3rd week or 4th week, lab will be available, and it will be given for free for a week or 2, that 8-node cluster. So I will let you know. You will be the first few candidates which I will let you know, and you will get 1 week additional time than others. You can test it out, and if there are any issues on the lab, you can revert back to us. We will try to resolve it and make it as reliable as possible. So the way we want to provide the lab is 2 ways. One is the way CloudX Lab is providing using command line. Okay, and the other one is people who are interested in taking the certification. We want to provide a remote desktop also, the way they get the environment when they go for the certification. So we will try to provide access in both ways, using remote desktop as well as the command prompt. So people, but the remote desktop approach will not be for a very long time, because it takes a lot of resources, and we have to come up with a lot better infrastructure for that. For that reason, we will only give on request basis. Whenever you want that remote desktop access, we will give that on request basis for 1 day or 2 days or a week. It depends. So you can get whenever you want. So we try to provide it the ways it is useful for the candidates, and the cost will be around $65 for 6 months, or 55 or 65. I do not remember. Whatever I have communicated earlier, we will be charging that for the first set of students, and then depending upon our experience, we will try to fix and we will try to change rates a little bit, but it will not change significantly. Okay, so that's the plan. So next week we will continue with the data frames, and then once the data frames is done, I will at least give all you about Kafka and Flume and show some demos on those things, and then we will go on to the setting up cluster, and we are actually testing the labs currently. Once the labs are properly tested, even if you want to build a multi-node cluster, let us know. We will provide the environment to you at $150 per month cost for Hadoop administration. For developer, it will be $55 for 6 months. And then we will take it forward depending upon our experience. So any questions here before we wrap up for today? Okay then. Thank you very much. We'll catch up as part of the next class. Have a nice one. Bye. I think I missed a question. Anyway, we will. Okay, chat. Yeah. I didn't miss any question. Thank you. Bye. So people who are on Google Hangout, thank you very much for joining the session. There was a mute time for some time in the middle. I got distracted and I forgot to unmute. Sorry for the inconvenience for those 5 minutes. Anyway, as you see, this is how my classes go on. If you are interested in taking up those classes, you have to fill up a form. I will annotate on all these videos. You can fill those forms, and then we will announce